Greetings. So my name is Graham Warren, and we're working on some AnyLogic models for the Antico Cafe Greco case. So the first thing is let's have a look and see if we can, you'll load up AnyLogic, and I'm running on a Windows box, but you may be on a Mac. And the first thing that I want to do is just clear out the welcome screen, and I want to create a new model. Now, I'm going to just call it, let's just say ACG model. Case in there, and I'm going to say finish. It's creating a new model. And I want to make sure that when I go into this projects setup here and I click on this, and I want to just make sure that my time units are in minutes. I'm going to do this model in minutes. So let me just explain, what I'm looking to do here. The first thing I want to try and set up is an MM1 queue. So you've got these customers coming in. They basically wait for a barista and then for the machine, and they get service. And so each of these, and then they leave the system, right? And so each of these, and there's a number of waiting spots here. So the arrivals are at the rate of 39 per hour, and the service is at the rate of 43 per hour. And what I'm going to assume in this initial model is that this is a Poisson process. We're modeling an MM1 system with exponential service. So those two assumptions are key. That the fact that I have in exponential inter-arrival times and exponential service times, that's what makes it an MM1. Of course, there is just one server. And then it's the same thing for the other two Venus, whatever, coffee makers. And what we're able to do is we're able to just analyze each of these separately because they're completely independent. Each of them has MM1 system. So, we don't have to do this 3 times because they're identical, right? So that's the essence of the analysis. Now, what I can also say is that if I have arrivals at the rate of 39 per hour, that is the same as 0.65 per minute. And the reason I'm giving you this is because I want to do this whole thing in minutes, and this is 0.717. Now I know I've got some rounding going on here, but so be it. All right, so that's the setup. That's what we're after. Now, to get this thing to go, I'm just going to clear that. Well, maybe I can leave that. I'm going to go ahead and go into my palette. No, I probably need to clear it. Okay. I'm going to use these process modeling blocks. So we're modeling an MM1 system. I need to use a source to create customers. I'm going to go ahead here and just make sure that I've got what I need. I'm going to make this an inter-arrival time setup. And then I'm going to have these customers arrive every 0.65 seconds. I'm also going to put a (0) in here, just specifying that the minimum value that is allowed from this distribution, these inter-arrival times, is 0. So I'm going to just go back and show you what I've done there. Exponential 0.65 and 0. That gets me my Poisson process with intensity of 0.65 customers per minute. I also want to do something here. I'm going to limit. So this is the free version of the software, and we can only do 50,000. Only generate 50,000 agents. These customers are agents. Let me just go back in here, and I'm going to create an agent type, which I'm going to call customer. So these are just our customers coming in. You'll see it's changed it. Where's my block on? It's kind of weird. Oh, I need to go back to main. Okay. So you can see I've got a customer there. And I think we're good here. Okay. So debugging these things is a little tricky. And what we're going to do is we're going to use our MM1 queuing theory to get an estimate of our wait times, expected wait times in the line, and the expected number of customers in the line, just to make sure that we've debugged our model, hopefully correctly. All right, so the next thing I want to do is I want to create a resource pool. And this resource pool is going to be our second type of agent, and I'm going to call them the barista pool. Okay, now they are portable. This is just some technical stuff, portable resource types. There's a capacity of 1 because we're analyzing just that MM1 system. So there is only one type. And so these are, I need to create a new custom type here, barista. Okay, so there's 2 types of agents, baristas, and okay, so now it's created a separate tab. I need to go back to main, and I just want to make sure I've got the right stuff here. So when capacity decreases, just open this up a tad so we can see what we're doing. I want to get statistics on these guys, notably utilization. And I think I have everything I need there. Okay, so now what happens when these customers come in? They're going to grab a resource. So I want to get C's here somewhere. There it is. We're going to seize a barista. Let's see if I can drag this out just a tad. And then I'm going to go in here and just say seize barista to make it clear what we're doing. These names of these little modeling blocks have to be without spaces. That's why I'm doing that. And I'm going to, they're going to seize from the barista pool. They're going to seize units 1 by 1. I'm going to allow maximum queue capacity so that folks, can line up waiting for a barista indefinitely. And when they get one, they're going to seize him, seize her, and proceed through the system. Also going to get some statistics here. And then we actually go and make the coffee in the delay. Just to extend that a little bit here. Okay, and the delay is going to be called make coffee. Just a name. Now I need to change the distribution. It's exponential service times, and it's 0.717. That is 43 per hour. It's 0.717 per minute, and I want to have the minimum value be 0. So we can do maximum capacity. And I want to get statistics here also. Now, the customers that are going to be going through this delay are actually the customers. They're they've seized the barista and they're carrying them through the coffee maker, so to speak. So just a way of thinking about how this model works. Then I'm going to release this barista. Let's just open this up again. I want to move that and get a little bit better. There it is. So we're going to call this one release barista. Okay. What else? So there's really a ton of stuff here, as you can see. Customer looks about right. Now we need to make sure we just release the 1. So I want to just specify it, and we're just going to release the 1. And the type that we're going to release is the barista pool. So we grab the barista here, make the coffee, release him, and then that customer goes on to customer heaven in the shape of a sink. We need to dump these satisfied customers somewhere, and they just go into a sink so that we don't have memory just piling up on us as we simulate. All right, so that is basically the process. When I run it, I'm probably going to discover that I've got some concerns, but let's go get some statistics going here. So I want to measure the time in the line. Firstly, I can just add some statistics immediately here. So I'm going to just grab some statistics here, call that barista utilization. They are going to be continuous. And the thing that I want to get is the barista pool utilization. So I can just, it's got a feature or parameter utilization that allows us to immediately capture what's going on there with the utilization of that one barista. And I think we're good on that. Then I want to put in some histogram data here to capture the queue length. So I'm going to call that queue length data. So we have to create this histogram data. And what I want to get is I want to get the queue length of this. There's a little queue sitting in this C's barista node, and I want to get that recorded, and it's going to be, let's see, size. It just gets us the size of that queue. And I think we're good there. So let me just move that away a tad. And then I can create a histogram from that data. So I'll plug this in here. And I'm going to call this queue length chart. And it's going to give me, the chart for queue length data. I think we're good. No, am I? No, sorry, it's not good. I want a histogram. There it is. I'm going to show the mean on this. It's going to be called queue length chart. I'm going to label that as well. It's just the titling. And then this grabs this queue length data that I've been collecting. And you can go ahead and change the colors and stuff that you want. You can make this thing horizontal as opposed to vertical, have vertical bars and all that good stuff. But I think we're good at this point. Now, the last piece is I want to capture the time in the line. So to get that, I go back to my process modeling, and I want to, there's a start, measure time start. So before I get the seize the barista, I'm going to start that. And then I'm going to end that time measurement after seizing the barista, because that's when you're waiting in the line. When you're making the coffee, you're actually getting service. If you wanted to get the time in system, you'd put this time measure end right here. But I want to just get the time in the line. So there it is. And then I can, for this block, so for time measure start, I believe we're all good. Time measure end, I need to specify what it's actually measuring. So I have to go in here and just say it measured from when the time started. I'm put in data set capacity here, put in 50,000 because I can have at most 50,000 agents in this free version. And I think I'm okay. Now I'm going to just finally put in a histogram on this. So I'm going to move it down here, up a tad, and I'm looking for, this is the wait time distribution. I'm going to copy this down here. And I think that I am done. So I'll stop the video here and I'll pick this up. We'll see if we can run it to just a tad.